Now we will talk about stereoisomerism. Another form of isomerism is stereoisomerism. It arises when a three-dimensional arrangement of the bonds in a molecule allow different possible orientation in space. So when the orientation of bonds in a molecule changes in three dimensions, we will obtain stereoisomers. For example, we have this compound. The first one is called Z-butene, and this is its shape in space. Let's suppose the orientation of the bonds changed, which means that one of the CH3 groups moved upwards, so we will have a stereoisomer. So these are two molecules that differ in the orientation of the bonds. So it is called E-butene. We use Z if the two same substituents are on the same side. So two hydrogens are up and the two CH3 groups are down. If they are not on the same side, so each hydrogen is on one side, we label the isomer E. So we have E-butene. So stereoisomerism depends on the orientation of bonds in space. If the same substituents are on the same side, then this is Z-isomer. If the same substituents are on opposite sides, this is E-isomer.